Hey, it's Miss Merriweather again, here to do your second video. So first thing you need to do is you need to open your Foldable to Continuous and Discrete. When you open it up on the top part, or I guess on the bottom, however you want to do it, you need to write your definitions. So take a second, pause the video, and write your definitions. Now that you have your definitions down, let's talk about them. First one says continuous, a graph made up of connected lines or curves. The key word there is connected. Anytime your graph is continuous, it is connected. A discrete graph is made up of unconnected points. So your key word there is unconnected and points. Anytime you have points that are not connected, it is discrete. A good example is a scatter plot. So no matter what, if you are given a graph that is a scatter plot, it will always be discrete. So moving on, you must look at your domain, which is your x values, to determine if the graph is continuous or discrete. So make sure you have that copied down. Discrete graphs will never have partial amount of x values. And I know that kind of sounds confusing. And what we mean is if you look at your x values or you look at your domain, you ask yourself, can I take partial amounts of that? So for example, humans or people, you cannot have 3/4 of a human, or you cannot take 1/2 of a human. Same thing with money. You cannot have 2.3687 of money or of a dollar. It's not going to be worth anything. Other examples may be a TV. You can't take 5/6 of a TV and it be working. So if you cannot take partial parts of it, then your graph is discrete. So moving along, we're going to actually look at a few just graph examples here. So here are some basic graph examples. Obviously, if it's a scatter plot, it is discrete. Notice that the lines or the points are not connected. Then you have continuous. If it is connected, it is continuous. Now be careful on continuous graphs. It can come to an end. That is okay, as long as those two endpoints are connected. It also may have arrows. Okay, school's out. Okay, it also may have arrows. If the arrows are there, the graph is still continuous as long as it is connected. So the key thing you're looking for is a connected graph. Now on a test though, it won't be that simple, so I gave you some test-like examples also. Test-like examples, they will actually give you your x values and your y values, and they'll tell you what it's representing. So again, if you look at your x values, you only have to look at your domain. Let me zoom in.
Teachers and staff, this is a reminder that if you haven't taken your faculty pictures, please head down to the spectator gym now. Thank you.
I guess y'all heard that. We all took our pictures. Okay, if you look here at your x values, it says people. So before, can we take partial amounts of people? Well, no. So that means this graph would be discrete. Okay? And then if you move it over, you look over here, and this one is talking about time. Now, can you take partial amounts of time? Well, yes, you can, because it goes down to minutes and seconds, and you can even take partial amounts of seconds. I don't know if that would be milliseconds. So if you can take partial amounts of time, then the graph is continuous. And here's another example. Just because it has an arrow, that still means continuous as long as it is connected. Well, I hope you got all this copied. Go back if you need to, and be ready to fill in the next section tomorrow in class. And y'all have a good evening.